Hi there, Mr. Rootsard here again, and today we're going to take a look at gravitational potential energy. This is actually a fairly simple concept. The math that's involved here is a little bit more detailed, through a manipulation of this equation. But basically, gravitational potential energy, we've talked a little bit about potential energy in class. It's the ability to do work. Now, gravitational energy is, potential energy is the ability to do work, or how much potential energy an object is going to have based on really its relationship to a point or a reference point below it. So if I hold an object up in the air, so for instance, if I have a ball and I put that up in the air and I have it over top of a surface, it is going to have a certain amount of potential energy that it gains basically to do work on this surface below. Now that potential energy that it has is going to be directly related to a number of different things. So if we look at the equation that I have here, first of all, the amount of potential energy that an object has is going to be equal to its mass times the acceleration of gravity times the height that it's at. So for instance, if I have a golf ball and I take that golf ball and I hold it, let's say just above the floor, and I put it a meter above the floor, how much potential energy will that golf ball have? Now remember, it has potential energy based on its position as long as it's not in motion, or we measure it without it being in motion. So if I have that golf ball and the mass of an average golf ball is equal to 0.045 kilograms, and we always put our mass in kilograms here. So if it is given to you in grams, it's converted, and the acceleration of gravity is 9.81 meters per second squared. And I know, let's say that we put it at a height, and our height or distance here is going to be measured in meters. So let's just put it at 1 meter, just to make the math a little bit easier. Okay, and if I want to calculate the potential energy that this ball has by putting it 1.0 meters above the ground, and I know that the mass of my ball is 0.045 kilograms, and I know the acceleration of gravity, I should be able to calculate this. So let's do that right now. So potential energy is equal to mass times gravity times height. My mass is 0.045 kilograms times 9.81 meters per second squared, multiplied by my height, which is 1.00 meters. Okay, and that's going to give me an answer to 0.4415, and our answer is in joules. So that tells me that this object has, when it's held above, the potential energy that it's going to have above the ground here is 0.4415. If I put that into significant digits, 0.442 joules. Okay, so that's its ability to do work. That's how much energy this object has. Take a look at the next video, because now we're going to relate that to kinetic energy and use that to see how fast the ball is actually traveling when it hits the ground. We will see you in class. Science.